We're solving problem 18 from the 2024 AMC 12A. On top of a rectangular card with sides of length 1 and 2 plus square root 3, an identical card is placed so that the two of their diagonals line up as shown, AC in this case. We want to continue the process, adding a third card to the second and so on, lining up successive diagonals after rotating clockwise. In total, how many cards must be used until a vertex of a new card lands on exactly the vertex labeled B in the figure? So in this figure, we have the smaller length is 1, and the larger length is going to be 2 plus square root 3. Now what we can do is construct midpoint P of segment AC and construct segment BP. We know that since this is a rectangle, all angles are 90 degrees, so therefore the lengths of the diagonals are equal, therefore the lengths of AP and PB are equal. So we can use the Pythagorean theorem to find what length AP is. AP squared is equal to, this P is a midpoint, so it's going to be half of the height, which is 1 plus root 3 over 2 squared plus a 1/2 squared, because this segment's 1/2, because half of 1. This, when you multiply it out, sum it up, yields to 2 plus root 3. So we get that AP is also equal to this length. This is not, figure is not drawn to scale, but it's supposed to be like that. So then what we can do is, well, we already used the Pythagorean theorem here. We know the lengths of these diagonals. Next, we want to find the angle made here on this figure when you add one card, so that you can divide the total amount of angles by however much that angle how much the angle here is. So we do this by applying the law of cosines with this angle. This total length is 1. So 1 squared plus AP, 1 squared equals AP squared plus AP squared minus 2 times AP times cosine angle APB. So 1 is equal to 2 times the square root, or 2 times 2 plus square root of 3, times 1 minus cosine angle APB. When you divide everything and then subtract that over, cancel out the negatives, and rationalize the denominator, you get that cosine angle APB is equal to root 3 over 2, or 30 degrees. What this means is that every time a new card is placed, the angle changes by 30 degrees. So therefore, angle BPC 180 minus 30 is 150 degrees. So we have 150 degrees left to fill. Then we do 150 divide 30 degrees. This is how much more cards are needed. Plus the one initial card gives us 6 cards. That's our answer for this problem.